This is the 10th part of this session where I will be exploring the powerful features of GitHub Actions and discuss about different runners in it. So in this session, we are going to see different workflows, wherein some we will be using runners. Some of these use cases we are going to see are how to run GitHub Actions in self-hosted runners, how to schedule cron jobs in GitHub Actions, and if any caches or artifacts are created in one job, then how to delete those in a scheduled manner. So here also you can see that these two jobs are running in two different runners. One is Ubuntu runner and the another is Windows runner. So in the next slides, we will be seeing how many types of runners are present in GitHub Actions. So there are different types of runners in GitHub Action. GitHub Action use runners to execute the jobs in a workflow. So 3 types of runners are there. The first one is self-hosted runner. So these runners can be installed and run on developers' own infrastructure. They can be used to run jobs on a developer's own machine or in private cloud. This allows developers to have full control over the environment in which their job run and to use specialized tools or configuration that may not be available in GitHub hosted runners. Then the second one is GitHub hosted runner. So these runners are provided and managed by GitHub. They run on GitHub infrastructure and are available in Linux, Windows, Mac OS environment. They provide a convenient way for developers to run jobs without the need to manage their own infrastructure. So lastly, there are third-party runners also. These runners are provided by third-party providers and can be used to run jobs in a specialized environment or using specialized tools. So this is used to run jobs on cloud providers such as AWS, GCP, or to run on a specialized hardware such as GPU. Additionally, GitHub Actions also provide the option to run actions in Kubernetes using GitHub Actions that allows to run action inside a Kubernetes cluster, which scales and manages the resources by the action. So each type of runner has its own advantages and use cases, and developers can choose the type of runner that best suits their environment. So let me show you the first use case which we have decided. Basically in this session we will be discussing 3 use cases. The first use case is how to execute workflows in self-hosted runner. So the first type of runner that we discussed, so we will be demonstrating that. So here you can see, so what you need to go is you need to go to, so this is the picture here. You need to go to the settings, then the actions runner, and then you will see this page, new self-hosted runner to run these commands. So there are n number of commands that we need to execute in the EC2 instance to create a self-hosted runner. So basically that EC2 instance will be self-hosted runner and all the workflow pipeline will be running on that EC2 instance. So we will not be using GitHub hosted runner. We will be using our own runner, which will be this EC2 instance. So let's go to this home. So here you can see, if I go to the actions and click on the runner, these are the commands you will be seeing that first we will be creating a folder. Let's check here. First we will be creating a folder actions runner. Then we will go to the actions runner folder, and then we will be downloading this file, then echoing this file, then we are unzipping this file, then we are running this command with a token in it, and then the self-hosted runner is installed for this. We can create an n number of self-hosted runners. So we have only created one for now. Then we have, if there is already a runner present, then we have to provide a name. If this is the first time, then we have to write enter, and then we have to provide a name for the runner so that it can be distinctly identified. Assume there are n number of runners, then how will you identify? Okay. So then you will provide a label. Okay. Then you will be providing a label for the runners. So these labels will be helpful when you will put into your pipeline. So by using this pipeline, the workflow will indicate that we have to use this EC2 instance as a runner and not the GitHub Actions as a runner. Okay. Then provide a work folder for your working everything you need to work. So for me, I have pressed enter and it is by default taking dash work. So now you can see that these all files are created by default. Okay. So what is happening is like, first, if you want to configure the self-hosted runner application as a service, so whenever you stop the EC2 machine, so what will happen is that self-hosted runner will stop automatically. But if you want to start it continuously, so what you need to do is like, you need to configure some things. You need to configure the self-hosted runner application as a service so that the runner is up and running if your application Linux machine is up and running. Okay. So firstly, what you need to do is install this service. As you can see, /service you need to first install and then start. So now what will happen is like, after starting the service, it will automatically start. It will continuously start the service. And although if you have removed the terminal, means you have exited the terminal, still it will work. Like it will the EC2 instance will like the self-hosted runner will all continuously run. So if you check here and refresh, let me refresh and go to the actions and runners, you can see that the Spring Boot application runners is running and it is still idle, but it is in the running state. Okay. So this is all. These are the commands which I have represented in the slides. So yeah, how you can assign the self-hosted runner in the workflow. So since this is the job workflow that I have added. So here you just need to put the target names that you have added in the EC2 instance. For me, I have added self-hosted, so I am adding self-hosted. It will directly automatically recognize that EC2 instance it needs to run. Okay. So the second use case that we are seeing is to schedule a cron job in a GitHub action. So what you need to do here, so this is the cron job. So this will run every 3 days. Like you can automate according to your need that when you need to run this cron job. So this is the way we need to run the syntax of the cron job. It's on. This is the on parameter which has a schedule, and we have this cron parameter where we need to put the cron syntax, and then it will run automatically. Let me go to the directly into the pipeline. If I go to the pipeline here and click on here, let me show you the pipeline. Yeah, this one. So this is the cron job. So first you need to create a new workflow in your GitHub action. Then this schedule trigger, you need to add a schedule trigger to the workflow. This can be added by this section. So the schedule trigger uses a cron expression to define the workflow should run, and then it will run basically. So let's go to the third use case. Yeah, if you want to delete the build artifacts which are present in Spring Boot workflow and also clear the caches using cron job, this is the whole syntax we actually every 3 days. So this is the whole syntax that we are doing. So here is the cron job. What it is doing is like it is deleting the artifacts. Artifacts means, I will show you the artifacts basically. So these are the artifacts that gets created by the build job. basically we were building our application, right? So some repository we needed in the new job. So we have created a artifactory and uploaded it in one job, and in the another job what we have done, we have downloaded this build file. So these artifacts are created in the GitHub Actions memory, and we need to delete it. Otherwise, the GitHub Actions memory allocated, it will increase and it will exceed the amount of storage. So we need to regularly, maybe not every day, but weekly, we need to delete all the artifactory so that it cannot consume the whole memory. So we are going to delete the artifacts every 3 days, and we are also deleting the caches that is being used in the workflow. For TF and TF6, there are some caches that we require. That's why these are getting created every time. So these needs to be deleted every time. So that's why these jobs need to be run. So here what we are doing, in the first job we are deleting. This is the expression. It is triggering every 3rd day. It is running on the Ubuntu latest machine. Using this action with the token ID, it is deleting every artifact which is present there. And in the clear cache, what it is doing, it is using this action easymon wipe, and every time it is deleting the caches. So let me show you how it is deleting. For currently now you can see that there is a build artifacts here, and there are some caches present here. So what we need to do, basically we cannot show you the cron job which runs after 3 days. So we have used this workflow dispatch. What it will do, like, we can manually trigger the workflow. So if you are able to see here that there are 2 jobs. One is delete artifacts and another is clear cache. So this is deleting the artifacts part, and this is clearing the cache. And this workflow dispatch means we are triggering the workflow manually. Okay. So if I go to the actions part and click on this delete artifact and run workflow, and then just click on the run workflow and click on this actions part, we can see that this delete artifacts YAML file workflow has run. So now you can see that the delete artifacts has run and all the artifacts has been deleted. I will show you the artifacts is been deleted or not. And even the clear caches hasn't. So these 2 jobs has run successfully. Now let's go here and click. This is the build one. If I refresh it, you can see that it's got deleted. The previous build that has been created is deleted. And if I click here, let me refresh it. And if I go to the caches, the caches is being deleted, and if I refresh, all the caches has been deleted. So let's go to the slide. So this is the slides that shows a build, and this is the TF int. So now it is all deleted. So this is the so this covers the whole part of the 3rd use case. So this is all for the last session. Thank you everyone.